Okay, I'm going to talk really quickly because I want to do two things in this episode, and if I run my mouth too much, it'll have to be into two separate ones. I want to keep this below 20 minutes. Sorry for the noise, my 3D printer's running. It's looking really cool. I'll put a picture there, probably. Yes, so, lines. If you have a point over here, and a point over here, if you want to take information from this point and put it over here, you just use a wire. Now, if you want to put information from this point to this point, you can just run it through the same wire. However, in Minecraft, that doesn't work because of the 15 block limit. So if this is, say, 20 blocks, and you've got each of your bits, this is not 15 or 20. So say if it's going this way, you can only get up to here before you need a repeater, and there's only one way. So if you send a signal up this way, it works, and that will go through to here. But if you try to send one back, they're only one way, so it won't go through there. So basically what I'm trying to do is make a contraption that will allow me to get a thing. It's essentially a two-way repeater. So like if you put a repeater there, like that, but then, okay, so I don't know how well you can see that. There's a glare from something. Is that the, might be on the screen. Yeah, so if you have something over here and you run a charge through here, it'll go along here, go down to here, go down to there. It can't go through that one because it's pointing that way. That one's pointing that way. But so run along here, go through there, run out here and along there. That is not enough because it will also run along here, which will then send the current along there. So if you take that way, it'll still keep running through because it'll just do an infinite loop of power. So yes, that's it for this bit, the explanation. Now Minecraft. Okay, so this is an example of what I meant. If I power this end, it all powers through, it all works, but if you remove that, it stays on, and the only way you can do it is by breaking one of them. So essentially what we need to do is have, like any block, there, and there, and then move them out the way. Say if we want to go over there, we just do that, and then that turns off, and then we can put the block back. Something like that. Okay, so I was thinking of something like this. So this runs into here, starting on this side, runs into here, powers this, which pushes this block out of the way, which pulls this across so that it can't push down its block on there, but also retracts this, powering this piston to push down the block. And that should be okay because pistons retract quickly, and it's just the same mirrored on the other side. However, if I run this, lots of stuff happens. It's very complicated. I don't understand half of it, but some of this, like if I remove this, it's all messed up. And if you reset it, it still doesn't go back down. It's probably something to do with bud powering, because if you remove this, then that works, and then you put it back and it just fixes it. This was my main idea for how it would work, and the fact that it doesn't work is slightly annoying. But anyway, I'll try something else. Essentially, it's the redstone blocks which are messing it up. Okay, so I've come up with something that works. Looks a bit odd. Basically, if you power it from this side, that block lifts up, so the signal goes out that way. If you power it from this side, that one lifts up, and it runs through that way. What's happening is the power's running along here, it's getting to this one, and then shooting through this block, and this is a signal strength of 15. This hopper has nearly full, so this will stop. This takes out nearly 15, so 14, and then anything that isn't 15 will be deleted, because this is 14 minus whatever's in here. So if this is anything, so this is 14 or less, then this is 0, so it doesn't output anything, like it is now. If this is 15, so if this repeater is run through and is powering out, then that's the only point this will power, which will unpower this torch, which will unpower this piston and lift up that block to stop it running around the edge and through this repeater, and then down to here and doing the loop. And then it's the same on this side, stopping anything other than a signal strength of 15 coming through and turning this off. It's a bit like it's got a chunky little footprint. That's what you call it. But it works. I will be tinkering between stuff just to get it to work better and be smaller. But for the meantime, this is it. Yeah. So this will be every 15 blocks will be one of these. Yeah. So then that should allow you to string them along for quite a while. I'll just make a demo over here. Okay, so I've just put 2 of them in a row. This a piston arrangement here is when you power the top one, it powers it and takes the signal over to the other lamp on the other side, just like this. And it works in this direction, which is lovely. And it works, sort of, if you string them along. You just need the right timing for the pulses, because there's a 2-tick delay on each of them before it works. So yeah, you have to factor that in. But yeah, other than that, it works perfectly, sort of. Yeah, cool. It also, if you give me a second to get over there, works in the other direction. So that turns on as well. And it works in the same way, which is very good because I do not know what I would have done if it didn't work both ways. Okay, so the next step is to get this to be able to split off into different sections. So this is the basic shape of what's going to go on. This is going to be a starting point. In this section here, there'll be something which changes the direction, so putting it from there to there and change it to there, or keep it going that way, and then there, or keep it going forwards. Yeah, I kept these just so I can put them there. Okay, so I've done some stuff to it. So this section is just that bit. Then these are the different directions. This works by, well, basically, if you start here, runs along there, through this target block into this comparator, which powers this section. If you power, say this one, not that one, if you power that far one, then it takes, this repeater takes this power from over there, and it routes it down here and along this strand to wherever this is, and then this redstone dust takes the power from this block, which only happens when it runs along here. It doesn't connect to this line, so only when this is powered does this turn on, which then subtracts from this comparator, which stops the power from here going back into here, which I could probably use for that, actually. Yeah, that's, yeah. So it subtracts that and stops the power running back through it. So it routes it over there. If you change which one of these it's on, then it does exactly the same thing. So it's putting into here, out there, taking away so it doesn't go back into that and cause a loop. Then it's going back through here, going all the way through here, and then this is the same setup. So if you do that, it takes it over there. What I need now is a way to power these because you want to be able to choose the direction. If you're over here, you want to say, oh, go right on this one, maybe go left on the second one. And you need another line across here to say which one you're doing. This is what I came up with very late at night. Yeah, it kind of works. The default is this one, so default having stuff run along that way. Then if you power this one, it turns off, well, this is if they're both off. This one's if they're both on, and this one is anything in between. So this is an and, no. This is an and, this is a NAND, and this is an OR, but without the and one. It's very complicated, doesn't work very well, so I'm not going to be using it. So this can all go. It was very late at night. I do have a slight bit of excuse. But this will all go. I've come up with another idea, and if it sort of works, then I'll show you that bit. Okay, so I've got most of it working. It's a bit spaghetti stone. This is the same section, it's just this purple bit that I've added. Basically what this is doing is, it's a logic gate, like over there. So if there's a charge here, so if there's any power running through here, this will turn off and go there. If this is greater than 15, if this is 15, because that's 14 going into the side, so if this is 15, it's the only time this will turn on. So if there's power running through here, this will be 15, turning it off, but this will be also on, which will turn this off, which will keep that off, and that will run into there. So if it's running along here and down here, it won't turn this on. However, if there's a charge here, but it's not 15 when it gets to here, so if it's just running along here and gets to here, then this one won't turn on. This one will be off, which then turns this off, which unpowers this, so that turns on, and then runs along here and powers this. So if you do there, that goes over there, and that's all good. However, if you turn that one on, and then run the current along there, it doesn't turn this one on, because it's got 15 in there, so that's on, which is turning that off. Yeah, that's it. This is possible because, essentially, I've reasoned that this will be like the core. Hang on, I'll show you a video of it on the whiteboard. Okay, so say this is our computer matrix. This is the core, where all of the instructions and stuff comes from, and then each of these is a different component. So say we have something from here, and it needs to get to here. It'll run through the core anyway, so it just goes to the core. If you want to get something from here to there, I mean, you could just do that, if it's like specifically for that thing, but then you just wouldn't need that one anyway. So you wouldn't even have that connection there. So that's essentially just a string. So you could just have it pass between those two components rather than the entire system. So essentially, any signal from any one of these will just run back to the core. So it doesn't need to like go left down here and then right down there. You don't need to have a signal ability for that. It just runs down to the core, and then the core will shoot it off somewhere else. So that means that if we say the core is over here, then any signal coming along this wire or along this bit will only pass down there. So you don't need to be able to change, like have pulse from this way go off on the right. It will just always go left. So you don't need any functionality for that. However, if it comes along here, you do need to be able to decide between going straight forwards and going right. So I need to get that sorted. Yay! Bye. See you in a bit. Like this has taken me hours for some reason. Bye. Okay, so it works. It's just absolutely massive. There's just this bit at the top. This would be the wire that runs along the top, so this would be the second wire, the control wire. So if this is off, then it's telling it to send the signal forwards. If it's on, it's telling it to send the signal to the right. So like that, it just switches between those. This is a system exactly the same to this. So if this has power, but not from that bit, then it pushes that up and allows the signal from this wire to pass through here and then trigger this one. Yeah, so then that turns off. If you do that, it still goes left. If you do that, it still goes forward. Yeah, this works. So that's sending it forwards. If you power this line, it sends it to the right and cancels the forward one. This is not the most elegant solution, by far. So yeah, I'm going to still tinker around with it, but yeah. this, yes, this, I'm very glad that this actually works. Okay, so I've made a little change. It's a lot confusing. So this, basically, this is the line for changing the direction, and it's all the way over here. However, this line is directly above the first line, like the data line, and the control line is directly above it. This one is all the way off to the side, which like leans over this side. But it's basically doing the same thing, just it's a little bit taller. The control line is one block up, but that's definitely fine. Ignore that. Okay, so this is going up, and it's when this is powered, it's pushing up this block in whichever state it is, either there or there, depending on what signal is going through the control. So when it's up, when this control thing is on, and that's powered, it pushes it up. These are different, so they don't stick to each other, but it sticks to that, so that when it comes back down, it just pulls it with it. So because it's powered at the top, it's changed to go forwards. And if you unpower this during it, it will break it, because if you do that, it's not locked there anymore. And then this is unpowered, and it should go left, but it doesn't because you've broken it. But that's not a problem, because this will be on during the whole course of where you want to send it, essentially. So if I undo the signal, remove that power, and then put the signal back on, then it powers that one and sends it off to the left. Yeah, that works perfectly. Now I just need a way to distinguish between the first one and the second one, so that both signals can run along here. Actually, no, that won't be able to happen. No, mind, that's fine. Yep. Okay, so I set up a little control panel. Don't worry about this. These things are not at all important. They're just the powering to make sure that when you flick the levers, they're all in the right position. Yeah, so it's just to make sure that when you flick that one, it's going that way rather than forwards. Just to make it look nicer. So if you power without any push down, then it comes out. Hang on. Okay, I've just fixed it. So, second time's a charm. If you just flick it without either of the side ones pushed down, then it goes straight out the front. If you, say, want it to go out the left one, you flick the left one, and then turn it on, and then it comes out the left. If you want it to come out the right one, then you flick the one on the right, and it comes out. Okay, third time's the charm. So if you want it to go to the right, you hit the right one, and then send it power, and it goes out to the right. That is, yes, that is now done. That is good. If you do both of them, it will come out on the right one. Just because if these happen at the same time, so it is both wanting to go left and right, but for it to go left, the signal has to go straight first. So if it goes right before that, then it never actually reaches over there. So this one is set to go left if a current ever reached it, which it hasn't. So that's all good. So you turn that off over there, and then if I grab this, if I want to send a current back along there, oh, okay. So I found out what the problem was. This piece of redstone somehow was bud powering this or something, quasi connectivity, what's it? Can be fixed by doing that, which, yeah, it's a bit odd. Yeah, now it works. Send power through there, it automatically sends it along there. And this is the same for these ones. Powered. And these ones powered over there. I have a lot of things to put back, like that block, and that monstrosity over here, just because I was saying what could power each other. But yeah, that is actually the end now, so goodbye. Yeah, just kidding. Sorry. I've got an improvement. Okay, taking on from that, I've slightly improved this design. Instead of it being that big, it's now that big. Yeah, so the same stuff that's happening in this, that bit, is happening here. So it sends power along there, into there, on there. This is actually more compact than that over there, where that will take only a signal strength of 15 to turn on, and that takes any signal strength to turn off. So if it's any signal strength that isn't 15 running along this wire, then that turns off and turns that on. So essentially, if it's coming in from that way, it pushes this block out of the way, which stops it from running back again. If it's on this side, it runs along here. That will be a signal strength of 15, so it stays on, which turns that off, which keeps that closed. And then it runs into here, and then takes off the thing for going back. This is a lot smaller, a lot smaller. So yeah, that's good. Yes. Hang on a second. Okay, yes, this is not going to work actually. I probably should have checked that before I went, ooh, I made it smaller. If it runs along here as 15 away, it doesn't go any further than this first one, so that doesn't work. I'll see if I can change it, but because it's this comparator here which is doing the issues. So I'll see if I can change that, but if not, it might just have to be that big. Okay, it was a simple fix. You just need to lock this repeater. Well, I changed this from a comparator to a repeater, and then changed this from subtracting 15 from just locking it in place, and that works now. So that runs that down there, and that's locked it from going back, and it just turns off. This runs along here, just goes across, that's moved out the way, and it's 15 on this block. That's all good. I'll put this like a level above, just so like you can tell that it's an advancement on that design. Like those are just copies of that. Yes, okay. For like the 5th time today, goodbye, go home, good morning, and if I don't see you, good afternoon, good evening, and good night. Scene.